So to review from benchmark 11, a table is proportional if the ratios of the x and y values are equal. So if we look at x and y in this case, 1 to 3 cannot be reduced, so that's just the ratio. 2 to 6, we can divide both of them by 2, and that equals a ratio of 1 to 3. 3 to 9 also equals 1 to 3, and 4 to 12 also equals 1 to 3. All of these ratios equal 1 to 3, so this table is proportional. If we look at this next table, the ratios of the x and y values, the first one is 2 to 3, that can't be reduced, so that stays the same. 4 to 6 can reduce to 2 to 3. 8 to 12, if we divide both by 4, reduces 2 to 3. And 12 to 14, we can divide them both by 2 and get 6 to 7. So since this one is different, this ratio is different, this table is not proportional. So again, every single ratio has to be the same for it to be proportional. Also, to review from last class, a graph is proportional if there's a constant rate of change and the graph is linear, meaning it makes a straight line. If you look at this graph, each time to go straight up, we go up 3 and over 1, up 3 over 1, up 3 over 1, up 3 and over 1. So we're rising at a same rate of change, meaning the line is going straight and there's no dips or curves in the graph. Now we're going to practice graphing equations. This equation right here is called slope-intercept form. The m is your slope, and the b is your y-intercept. So the slope is your rise over run, and that's just how steep a line is. Your y-intercept is where a graph crosses the y-axis. So if we had our graph, this point right here, where the blue line crosses the y-axis, that's your y-intercept. Another word for slope, which we mentioned earlier, is rate of change. So if you hear slope, rise over run, or rate of change, they all mean the same thing. So before we graph equations, let's look at a few and pick out the slope and the rise over run from an equation. So if we had the equation y equals 2x, if we don't have any b, we can write plus 0, but we don't need that. Our slope, or our m, would be 2 over 1. Remember, we can always put a 1 under a number and keep it the same value. And then our b would be 0. That's where the graph is crossing the y-axis. If we had y equals negative 3x plus 1, our m is 3 over 1, and our y-intercept is positive 1. If we had y equals 1/2 x minus 2, our m is 1/2. That means we're rising 1 and going right 2. And our b would be negative 2, since that's a minus 2. If we had y equals negative 1/3 x plus 4, our slope would be a negative 1/3, and our y-intercept would be a 4. So we're just picking out the numbers from each problem to be able to start our graph. So if we were to graph the equation y equals 2x plus 0, we really don't even need that plus 0 there, and it'd still be the same. Our slope, or our m, is going to be 2, or 2 over 1, and our b is 0. So the b tells us where we start on the graph. So we're going to start at 0 in the middle, and the m tells us how steep our line is. So we go up 2, and we're going to go over 1, starting from 0. So we go up 2, over 1, and put a dot. Up 2 spaces, over 1, and put a dot. Up 2, over 1, and put a dot. And this could continue on, but we're going to connect the graph, connect the lines, and that's how we graph this equation. So our graph should look like this. And we can make a table from our graph. We have an XY table. We start at 0, 0. Then we put a point at 1, 2. Then we put a point at 2, 4. And we put a point at 3, 6. So this equation and this table have the same meaning. You can represent the same thing 3 different ways: an equation, a graph, and a table. Let's look at the equation negative 3x plus 2. Our m, or our slope, is negative 3 over 1, and our b, or our y-intercept, is positive 2. So again, the b is where we start our graph. So we're going to put a dot at 2 on the y-axis. Now since we have a negative 3, we're going to go down 3 and right 1. So we're going to go down 1, 2, 3, right 1, put a dot. Down 1, 2, 3, right 1. 1, 2, 3, and right 1. And then we're going to draw our graph by connecting the dots. So again, if we wanted to make an XY table from that, we started at 0, 2. Then we put a dot at 1, negative 1. And then 2, negative 4. And then 3, negative 7. Now let's look at y equals negative 1x plus 3. Our m, or our slope, is negative 1 over 1, and our b is positive 3. So again, that's where we start. So we're going to put a dot at positive 3 on our graph. And then this time we're going to go again down 1 and over 1. So we're going to go down 1, over 1, down 1, over 1, down 1, over 1. And then we can connect our dots to make our graph. And if we were to make a table, we started at 0, 3. Then we put a dot at 1, 2. And then we put a dot at 2, 1. And then our last dot is at 3, 0. So again, the equation, the graph, and the table all represent the same thing, just in different ways. Now let's look at equations where we have a fraction for a slope. So this time our m is going to be 1/2, and our b is negative 1. If it says minus 1, our b is negative. So we're going to start at negative 1 and put a dot at negative 1 on the y-axis. This time we're going to go up 1 and over 2. Our rise is 1, so that means we go up or down, and our run is 2. So we're going to go up 1 over 2, up 1 over 2, up 1 over 2. And then we still connect our lines. So our table would be 0, -1, 2, 0, 4, 1, and 6, 2. Now let's look at an equation where we have a negative fraction for our slope. So our m is going to be -1 over 3, and our b is going to be -1. So we'll start at -1, and this time we're going to go down 1 over 3. So we start at -1, we go down 1 over 3, down 1 over 3, down 1 over 3. And then we connect our dots to make our graph as best as you can. And then if we had our table, we would start at have 0, -1, 3, -2, 6, -3, and 9, -4. We can also look at proportional relationships when looking at different diagrams or shapes. If we look at the ratios of these sides, so this side matches up with this side of this triangle. So that's 6 to 18, and that reduces to 1 to 3. These two sides are the same, so again 6 to 18 reduces to 1 to 3. The bottom, this side to this side, 7 to 21 reduces to 1 to 3. We can divide both of these by 7 and get 1 to 3. So these two shapes are proportional because the ratios of the sides are proportional. Now if we look at these two shapes and match up the ratios of the sides, so this side to this side, 4 to 8 equals 1 to 2. This side to this side, 4 to 8 equals 1 to 2. This side to this side, 6 to 8 equals, we can divide them both by 2 and get 3 to 4. And same for this one, 6 to 8 again equals 3 to 4. So since all of these do not have the same ratio, these two shapes are non-proportional. So if we match up all the sides to its corresponding side, meaning the same side in a different shape, and all the ratios are equal, it'd be proportional, but in this case it's not. Please make sure to write down the definition of a corresponding side. This is the end of the video, and please start on the next activity.